Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss top 30 questions in alternative current. Okay, so here these questions, these top 30 questions are continuously repeated in KCET. Okay, so if you are able to solve these kind of question or this question, so you will be able to solve these kind of question in KCET. Okay, easily. Question number 1. In series LCR circuit at resonance, the phase difference between the voltage and current is. See, this one is, these kind of questions are repeated. Okay, finding the phase difference between voltage and current. So in series LCR circuit at resonance, the phase difference between voltage and the current is 0, right? Why it is 0? Because both are in same phase. The phase of voltage and current both are in same phase. Okay, so option D is the correct answer. Okay, next question. Question number 2. An ideal transformer has a turns ratio of 10. When the primary is connected to 220 volt 50 hertz AC source, power output is. What is power output? The power output is equal to voltage in secondary coil into current in secondary coil. Okay, here the ratio of turns is given, right? NP by NS is equal to 10, right? So we know that Vp divided by Vs equal to Np by Ns, right? Which is also equal to Is by Ip, right? So Vp divided by Vs also equal to 10, right? So Vs is equal to Vp divided by 10, right? And Is is equal to 10 Ip, right? Now the power output here, right, is equal to Vs is Vp by 10 into Is is 10 Ip. Here Ip, 10 and 10 will get cancelled. So power output is equal to power input, right? Power input. Vp into Ip is power input. So power output is equal to power input. So the correct option is B. Okay. Yeah. Next question. Question number 3. A total impedance of a series LCR circuit varies with angular frequency of the AC source connected to it shown in the graph. The quality factor Q of the series LCR circuit is. Okay, we need to find the quality factor Q, right? So this is the given graph, right? Impedance versus angular frequency graph, right? Now the quality factor Q is equal to omega naught. So what is omega naught? Omega naught is angular frequency at resonance, okay, divided by 2 into delta omega. Okay, omega naught is angular frequency at resonance divided by 2 into delta omega. What is 2 into delta omega? 2 into delta omega is bandwidth. Okay, so 2 into delta omega is equal to 600 minus 400, right? So which is equal to omega 2 minus omega 1, right? So 2 into delta omega is equal to 600 minus 400, that is 200 radian per second, right? 200 radian per second. And what is omega naught? Omega naught is 500 radian per second. Now substitute these values. Q equal to 500 divided by 200. Solve this, you will get 2.5. Okay, there is no unit for quality factor, right? So Q equal to 2.5. So the correct option is A. An alternating current is given by I equal to I1 sin omega t, I2 cos omega t. RMS current is given by. Okay, so here what is the meaning of RMS? RM is root mean square, right? Root mean square. Square, mean and root. First square the current, right? So I square is equal to, equation is given, right? Now square both side. I square is equal to, here I1 square sin square omega t plus I2 square cos square omega t plus 2I1 I2 2I1 I2 2I1 I2 sin omega t cos omega t, right? Sin omega t cos omega t. Okay, now we have squared the I, right? So next take the mean value or average value of the I square. Okay, average value of the I square. So what is the average value of the sine square omega t? So it's half, right? Isn't it? So average value of the sine square omega t is half, right? So I1 square divided by 2, right? Plus average value of the cos square omega t is half, right? So I2 square divided by 2 plus here 2 sin omega t cos omega t is, here 2 sin omega t cos omega t is sin 2 omega t, right? So what is the average value of the sin 2 omega t? It's 0, right? So it will be 0. Now take root both side. Here we have took the value of average value of the I square, right? So now take root, square root. So now this will be root of I1 square plus I2 square divided by 2. Okay, I1 square plus I2 square divided by 2. So this is the root mean square RMS current. Okay, this is the value of RMS current. The given current is I equal to I1 sin omega t plus I2 cos omega t. So the correct option is A. Okay. Next question. Question number 5. A fully charged capacitor C with initial charge Q naught is connected to coil of self-inductance L at t equal to 0. Okay, at t equal to 0. The time at which the energy is stored equally between the electricity and magnetic field is. Okay, so we need to find the time at which energy is stored equally between capacitor and inductor. Okay, that is electrical energy is equal to magnetic energy. Okay, yeah. So at time t equal to 0, what is the energy? The total energy. The total energy is energy stored in the capacitor, right? So here a fully charged capacitor uh, with initial charge Q naught is connected to the inductor, right? Isn't it? So energy stored in the capacitor is equal to total energy, right? So that is equal to half Q naught, half Q naught square divided by C, right? Half Q naught square divided by C. Okay, so this is the total energy, right? Now the total energy is equal to energy stored in the capacitor, okay, at time t plus magnetic energy or energy stored in the inductor at time t. Okay, at time t energy stored in the capacitor is equal to energy stored in the inductor, right? So now I can write total energy is equal to energy stored in the capacitor into 2, right? Um equal to ue, right? So total energy equal to 2 into energy stored in the capacitor. Now energy stored in the capacitor at time t is ue, which is equal to total energy divided by 2, right? Now ue is equal to half q square divided by c. Q is the charge on the capacitor at time t, okay, which is equal to total energy stored in the capacitor, that is half q naught square divided by c into half, right? So half into q naught square divided by 2c. Now solve this, you will get q equal to q naught divided by root 2. Okay, q equal to q naught by root 2. Yeah, so now we got the expression of q, that is the charge on the capacitor at time t, okay, in terms of q naught, right? So in LC circuit charge varies sinusoidally, right? So q equal to q naught into cos omega t, right? Charge varies sinusoidally, right? So here q equal to q naught by root 2, right? Substitute here q equal to q naught by root 2, which is equal to q naught into cos omega t, right? So now q naught will get cancelled, right? Cos omega t is equal to 1 by root 2, right? So omega t equal to pi divided by 4, okay? Omega t equal to pi by 4. So what is omega? Omega is 1 by root LC, right? How we got 1 by root LC? You remember second order differential equation. From there we will get the value of omega, right? So omega is 1 by root LC. Here omega square equal to 1 by LC. We get 1 by LC. We take 1 by LC as omega square, right? Omega is 1 by root LC from the second order differential equation. Okay, while solving that we will get this, right? Omega value 1 by root LC into t equal to pi divided by 4. So t equal to pi by 4 into root LC. So the correct option is C. Okay. A series resonant AC circuit contains a capacitor of 10 to the power minus 6 farad and an inductor of 10 to the power minus 4 Henry. The frequency of electrical oscillation will be. Okay. Here it's a resonant AC circuit, right? Isn't it? That is XL is equal to XC. This is the condition for resonant frequency, right? Or resonance. Condition for resonance, right? So we need to find the frequency of the electrical oscillation. That is F. We need to find the value of F. XL equal to omega into L. Omega is angular frequency, right? L is inductance, which is equal to XC. XL is inductive reactance. Okay, XC is capacitive reactance. XL is omega into L. XC is 1 divided by omega C, right? Now omega is equal to 1 divided by root LC. We need to find the value of F, right? So omega is 2 pi F. 2 pi F equal to 1 divided by root LC, right? So F is equal to 1 divided by 2 pi into root LC. Okay, now we got the final expression, right? Now substitute the values L and C. That's it. So F equal to 1 divided by 2 pi into root of L. L is 10 to the power minus 4 Henry, right? And C is 10 to the power minus 6 farad. So 10 to the power minus 4 into 10 to the power minus 6. Root of 10 to the power minus 4 into 10 to the power minus 6 is root of 10 to the power minus 10. So root of 10 to the power minus 10 is 10 to the power minus 5. So 1 by 10 to the power minus 5 is 10 to the power 5. So frequency F is equal to 10 to the power 5 divided by 2 pi. What is the SI unit of F? That is frequency, hertz. So the correct option is A. Okay. Yeah. Next question. Question number 7. In a series LCR circuit, R equal to 300 ohm, L equal to 0.9 Henry, C equal to 2 microfarad and omega equal to 1000 radian per second, then impedance of the circuit is. Simple one, right? Here we need to find the impedance. Impedance is equal to root of R square plus XL minus XC whole square. Okay. So this is the impedance of the circuit, LCR circuit. Okay. LCR in series. Okay, omega value is given, L is given, C is given, R is given. Substitute the values, that's it. Now Z is equal to root of R square plus XL is omega into L, okay, omega into L minus omega 1 by omega into C. XC is 1 by omega into C. Here omega into L minus 1 divided by omega into C squared. Okay. Now Z is equal to root of R square. R square is 300 square. Okay. Plus omega L minus 1 divided by omega C, right? Omega L, omega is 1000. 1000 into 0.9 is 900, right? 1000 into 0.9 is 900 minus 1 divided by omega C. Omega is 1000, okay? 1000 into 2 microfarad, right? So that is 10 to the power 3 into 2 into 10 to the power minus 6 whole square, right? Now here 10 to the power 3 into 10 to the power minus 6, right? This is equal to 10 to the power minus 3. 1 by 10 to the power minus 3 is 10 to the power 3. So 1 by 2 into 10 to the power 3 is 500, right? So Z is equal to root of 300 squared plus 400 squared, right? 900 minus 500 is 400. Now Z is equal to, so solve this, you will get 500, okay, 500 ohm. So the correct option is A. Okay. Yeah. Next question. Question number 8. What will be the reading in the voltmeter and ammeter of the circuit shown? Okay, so this is the given circuit, right? Isn't it? XL and XC both are in series, right? And it is connected to the voltage, this one, right? Parallelly, isn't it? Yeah, and voltmeter also connected parallelly to XL and XC, right? Okay. So now let us find voltage across XL and XC. Okay. See, the value of XC and XL both are same, right? Isn't it? Right? So the voltage V is equal to root of VR squared plus VL minus VC whole square. Right? So what is the value of VL minus VC? VL minus VC is 0, right? Isn't it? VL minus VC is 0. So V is equal to root of VR square. VR is voltage across the resistor, right? VR squared. So what is the value of VR squared? VR squared is 90 volt only, right? So V is equal to 90 volt. Okay. Now let us find the current. The current I is equal to V divided by Z, right? Current I is equal to V is 90 volt, right? 90 divided by root of R square plus XL minus XC whole square, right? XL minus XC is 0 because 4 ohm, XL is 4 ohm, XC is 4 ohm, right? XL minus XC is 0, R is 45 ohm, right? So 45 root of 45 squared is 45 only. The value of I is equal to 90 divided by 45. So I is equal to 2 ampere. So the correct option is A, 90 volt and 2 ampere, right? Yeah. Question number 9. A series LCR circuit contains inductance 5 millihenry. So this is the value of L. Okay. Capacitance 2 microfarad, C is 2 microfarad, and resistance 10 ohm, R equal to 10 ohm. If a frequency AC source is varied, what is the frequency at which maximum power is dissipated? Okay. So here we need to find the frequency at which maximum power dissipated, right? That is, here we need to find the value of F, right? So when will be the maximum power dissipated? When the circuit is at resonance, right? So what is the condition for resonance? Condition for resonance is equal to XL equal to XC, right? So XL is omega into L and XC is 1 divided by omega into C. 1 divided by omega into C, right? So omega is equal to root of LC, right? So F equal to 1 divided by 2 pi into root of LC, right? So F equal to 1 divided by 2 pi into root of L. L is 5 millihenry. So 5 into 10 to the power minus 3 into C. C is 2 microfarad, that is 2 into 10 to the power minus 6, right? So now F is equal to 1 divided by 2 pi into root of, here I can write this one 2 into 5, right, as 10. So 10 into 10 to the power minus 9, right? 10 into 10 to the power minus 9. Now I can write 10 into 10 to the power minus 9 as 100 into 10 to the power minus 8, right? So F is equal to 1 divided by 2 pi into 100 into 10 to the power minus 8. Okay. Sorry, 100 into 10 to the power minus 10, not 10 to the power minus 8. Okay. Sorry, 100 into 10 to the power minus 10, right? So 10 to the power, root of 10 to the power minus 10 is 10 to the power minus 5, right? Root of 100 is 10. So 10 into 10 to the power minus 5, right? So F is equal to 10 to the power 4 divided by 2 pi, right? 10 to the power 4 divided by 2 pi. Or you can write this as, 10 into 10 to the power 3 divided by 2 pi hertz. Okay, so f is equal to 5 into 10 to the power 3 divided by pi hertz. Okay, so the correct option is C, right? 5 divided by pi into 10 to the power 3 hertz. Yeah, next question, question number 10. In an oscillating LC circuit, inductance L equal to 3 millihenry, capacitance C equal to 2.7 microfarad, at t equal to 0, the charge on the capacitor is 0 and the current is 2 ampere. Okay, at t equal to 0, the charge on the capacitor is 0 and current is 2 ampere. The maximum charge that will appear on the capacitor will be. Okay, yeah. So we need to find the maximum charge that will appear on the capacitor, right? So how to solve this one? So let us write the charge equation, that is the charge varies sinusoidally in LC circuit, right? So Q equal to Q naught into sine omega t, right? Q equal to Q naught into sine omega t, right? At t equal to 0, the charge on the capacitor is 0, right? Now differentiate both sides with respect to t. Okay, actually this is Q equal to Q naught into cos omega t. Okay, so here I took sine omega t because at t equal to 0, the charge on the capacitor is 0, right? Yeah. Now differentiate both sides with respect to t. Now I equal to dq by dt, okay, which is equal to Q naught into differentiation of sine omega t. What is the differentiation of sine omega t? Omega into cos omega t, right? Omega into cos omega t. Now I equal to Q naught omega cos omega t, right? Now at t equal to 0, the current in the circuit is 2 ampere, right? At t equal to 0, the current in the circuit is 2 ampere, right? So here I equal to Q naught into omega only, right? At t equal to 0, cos omega t, here cos into omega into 0, right? So this will be 0. Now Q naught is equal to I divided by omega, right? So what is omega? Omega is 1 by root LC, right? So if you don't know how we got this one, that is omega equal to 1 by root LC, go through the derivation. Okay, the second order differential, from the second order differential equation we will get this one, the value of omega. Okay, so here Q naught is equal to I into root LC, right? Now substitute the value. Q equal to I is 2 into root of L. L is 3 millihenry, right? That is 3 into 10 to the power minus 3 into C. C is 2.7 microfarad, that is 2.7 into 10 to the power minus 6. Okay, yeah. Now Q naught equal to, solve this, you will get 18 into 10 to the power minus 5 coulomb. Okay, 18 into 10 to the power minus 5 coulomb. So this is the maximum charge that will appear on the capacitor. So option B is the correct answer. Question number 11. A step down transformer has 50 turns on secondary and 1000 turns on primary windings. That is, NS is equal to 50, NP equal to 1000, right? If a transformer is connected to 220 volt 1 ampere AC source, okay, 220 volt 1 ampere AC source, here Vp is equal to 220, Ip is equal to 1 ampere. What is output current of the transformer, right? So we need to find output current, that is Is of the transformer, right? Okay, so we know that Vp divided by Vs is equal to Np divided by Ns, right? Which is also equal to Is divided by Ip, right? Np by Ns is 1000 by 50, right? Vp divided by Vs is equal to 1000 divided by 50, right? Which is also equal to Is by Ip. Okay, so 1000 by 50 is 20, right? Vp divided by Vs is equal to 20, right? Here we need to find the value of Is, right? Ip is also given. Okay, Vp by Vs is Is divided by Ip, right? Is by Ip is equal to 20, right? Ip, the value of Ip is given, right? So Is is equal to 20 into Ip, right? Ip is 1 ampere. So Is, that is output current, is equal to 20 ampere. Okay, so the correct option is D. Okay, the direct question, right? Isn't it? Yeah, next question. Question number 12. In the given circuit, the resonant frequency is. Okay, so this is the given circuit, right? L and C circuit. We need to find the resonant frequency, right? So what is the condition for resonance? The condition for resonance is XL, that is inductive reactance, must be equal to capacitive reactance, right? XL equal to XC. So what is XL? XL is omega into L, right? Omega is angular frequency, L is inductance, which is equal to 1 divided by omega C. XC is 1 divided by omega C, right? C is capacitance. Now omega is equal to 1 divided by root LC, right? So what we need to find here, we need to find resonant frequency, that is Fr, right? Omega is 2 pi f, right? 2 pi Fr is resonant frequency, which is equal to 1 divided by root LC, right? Now Fr is equal to 1 divided by 2 pi into root LC. Okay, now substitute the values. Fr equal to 1 divided by 2 pi into root of L. L is 0.5 millihenry, right? That is 5 into 10 to the power minus 4 Henry into C. C is 20 microfarad, that is 20 into 10 to the power minus 6 farad, right? So now solve this. Fr, you will get Fr equal to 1592 hertz, okay, which is approximately equal to 1592 hertz. So the correct option is A. Okay, yeah. Next question, question number 13. In the given circuit, the peak voltages across C, L and R are 30 volt, 110 volt, 60 volt respectively. Here Vc equal to 30 volt, VL equal to 110 volt, right? VR equal to 60 volt. Okay, VR equal to 60 volt. The RMS value of the applied voltage, that is we need to find Vrms, right? We need to find RMS value of the applied voltage. Okay, yeah. Let us find the peak value of the applied voltage. The peak value of the applied voltage, V equal to root of VR square plus VL minus VC whole square, right? Now V is equal to root of VR square. VR square is 60 square plus VL minus VC whole square. VL is 110 volt, VC is 30 volt. 110 minus 30 is 80 square, right? So V is equal to 100 volt, right? If you solve this, you will get 100 volt. Okay, V equal to 100 volt. Now we need to find Vrms, right? So Vrms is equal to V0 divided by root 2, right? So this is the value of V0, right? So V0 is 100 volt. So Vrms is equal to 100 divided by root 2. Okay, 100 divided by root 2, isn't it? Right? So Vrms is equal to, if you solve this, you will get 70.7 volt. Okay, Vrms is equal to 70.7 volt. Okay, the frequency of an alternating current is 50 hertz. What is the minimum time taken by the current to reach its peak value from RMS value? So let us understand the question, this question. Okay, here the current varies sinusoidally, right, in AC. Yeah, So what is the value of IRMS? IRMS is equal to I naught divided by root 2, right? I naught divided by root 2. So this is the value of IRMS, right? So we need to find the time t, okay, or time taken by the current to reach its peak value. Here this is the peak value of the current, right? So what is the time? Time here t by 4, right? So from RMS value to peak value, right? Isn't it? So we need to find the current, time taken by the current to reach its peak value from the RMS value, right? So let us find the time, okay, the time when the current reaches IRMS, okay? Yeah. So what is the current equation in AC? The current equation is I equal to I naught into sine of omega t, right? Here we need to find t, okay? Here the value of I is IRMS, okay? IRMS is I naught divided by root 2, right? I naught divided by root 2 is equal to I naught into sine of omega t, right? So I naught will get cancelled, right? So omega t is equal to pi divided by 4, right? Omega t is equal to pi by 4. Okay. So now here, what is omega? In this case, omega is 2 pi by t, right? 2 pi by t. So 2 pi by t into t equal to pi by 4, right? So pi will get cancelled, t equal to t by 8, right? So current reaches the value of IRMS, okay, when time t by 8, okay? So we need to find the time, right? Isn't it? Time taken by the current to reach its peak value from RMS value, that is t by 4 minus t by 8. Here t dash is equal to t by 4 minus t by 8, right? Which is equal to t by 8 only, right? T dash equal to t by 4 minus t by 8, which is equal to t by 8, right? Now t dash is equal to t by 8, okay? So now we need to find t, right? Isn't it? That is capital T. How to find capital T? Here the frequency is given. Frequency is equal to 1 by t, which is equal to 50 hertz, right? So t, here t equal to 1 divided by 50 second, right? 1 divided by 50 second. Now t dash is equal to 1 divided by 50 into 8, right? 1 divided by 50 into 8 is 1 by 400. So t dash is equal to 1 divided by 400, okay? 1 divided by 400 second. So which is equal to 2.5 into 10 to the power minus 3 second, okay? 2.5 into 10 to the power minus 3 second. So this is the time taken by the current to reach its peak value from the RMS value. So the correct option is D, okay? Next question, question number 15. The readings of ammeter and voltmeter in the following circuit respectively. Okay, so here we need to find readings of ammeter and voltmeter, right? So first let us find reading of voltmeter. Now V is equal to root of VR square plus VL minus VC whole square, right? V is equal to root of VR square plus VL minus VC whole square. Here VL minus VC is 0, right? Now V equal to, that is reading of voltmeter, reading of voltmeter, right? Which is equal to root of VR square, right? VL minus VC is 0. V equal to root of VR square is VR only. So what is the value of V? V is 220 volt, right? So 220 is equal to VR, right? That is reading of voltmeter, 220 volt. So here VR is equal to 220 volt, right? So option B and C are, B and D are eliminated, right? So now we need to find reading of ammeter, right? VL and VC both are same, right? Isn't it? So potential difference across L and C is 0, isn't it? Right? So VL minus VC is 0, right? Okay. So here I equal to V divided by Z, right? Isn't it? So Z is equal to root of R square plus XL minus XC whole square, right? Okay, you don't need to write V by Z, okay? So it is V by R only because these three are in series, right? The current won't change, isn't it? So I equal to V by R only, right? I can write I equal to V by R. You don't need to find Z and all, okay? So I equal to V by R. V by R, right? So I equal to V is 220 volt, right? Divided by R. R is 100 ohm. So I equal to, if you solve this, you will get 2.2. So 2.2 ampere. So the correct option is C. Okay. Yeah. Next question. Question number 16. An inductor of inductance L and resistor R are joined together in series and connected by source of frequency omega. The power dissipated in this circuit. Okay. So this is LR circuit, right? Here inductor and resistance, okay, inductor and resistor, inductor and resistor of resistance R, okay, inductance is L, joined together in series and connected by a source of frequency omega. Okay, the power dissipated in the circuit, we need to find power dissipated in the circuit, right? Okay, so power dissipated in the circuit, P is equal to V into I cos phi, right? V into I into cos phi. Okay, so what is cos phi? Cos phi is equal to, here LR circuit, right? Isn't it? So let us draw the phasor diagram. So this is R or VR, right? VR, and this is VL, right? Isn't it? VR and VL. So this angle is phi, right? So this will be root of VR square plus VL square, right? So VR is I into R, VL is I into XL. Take I as common. So this will be R square plus XL square, right? Root of R square plus XL square is impedance of the circuit, right? Okay. So now cos phi is equal to VR, right? VR is I into R divided by here hypotenuse. What is hypotenuse in this case? Hypotenuse is here, hypotenuse is root of R square plus XL square, right? Root of R square plus XL square into I. So I will get cancelled. So what is root of R square plus XL square? That is Z. So cos phi is equal to R divided by Z. Okay. So now P, that is power dissipated in the circuit, is equal to V into I into R divided by Z, right? V into I into R divided by Z. So I can write I as V divided by Z, right? So power dissipated in the circuit, P is equal to V into R divided by Z square, right? Z into Z square. So now P is equal to here V square into R divided by Z is root of R square plus XL square. So in this case, Z square is R square plus XL square, right? R square plus XL. XL is omega into L. So omega square into L square. So this is the power dissipated in the circuit. So the correct option is here D. Okay. Next question. Question number 17. Which of the following represents the variation of inductive reactance XL with the frequency of voltage source nu? Okay. So this is nu, that is frequency F. Okay. So we know that XL is equal to omega into L. Inductive reactance is equal to angular frequency into inductance. So XL equal to omega is 2 pi into nu into L. So XL is directly proportional to frequency of the source nu, right? So the graph of XL versus nu will be linear. So the correct option is A. Okay. Yeah. Next question. Question number 18. A 100-watt bulb is connected to an AC source of 220 volt, 50 hertz. Then the current flowing through the bulb is. Okay. So this is the 100-watt bulb, right? Right. Is connected to AC source of 220 volt, 50 hertz, 220 volt, 50 hertz. Then the current flowing through the bulb, right? Isn't it? Now, the current flowing through the bulb, that is IRMS, is equal to VRMS divided by R, right? VRMS divided by R. R is the resistance of the bulb. Okay. So now here we need to find R, right? Because here only power is given, right? So power is equal to VRMS squared divided by R, right? So R equal to VRMS squared divided by P, right? Now IRMS is equal to VRMS divided by VRMS squared divided by P, right? VRMS will get cancelled. IRMS is equal to P divided by VRMS. Okay. Now IRMS is equal to IRMS is equal to P. P is 220 volt. Okay. P is 100 watt, not 220 volt. The power, right? Sorry. P is 100 watt. Okay. 100 watt divided by VRMS is 220 volt. Here 0 will get cancelled, right? That is 10 will get cancelled. IRMS is equal to 2 5s are 10, 2 11s are 22. So 5 divided by 11 ampere. So the correct option is A. Okay. The current flowing through the bulb is 5 by 11 ampere. Yeah. Next question. Question number 19. The average power dissipated in AC circuit is 2 watt. So P average is equal to 2 watt. If a current flowing through a circuit is 2 ampere and impedance is 1 ohm. Here current flowing through the circuit is 2 ampere and impedance Z equal to 1 ohm. The power factor of AC circuit, right? We need to find the power factor, that is cos phi, right? Now we know that P average is equal to VRMS into IRMS into cos phi. Okay. So if you want to know how we got this expression, go through NCERT. Okay. It is given. So P average equal to VRMS into IRMS into cos phi. Okay. P average is given. IRMS is 2 ampere, right? Z is 1 ohm. Okay. So now P average is equal to VRMS is IRMS into Z, right? IRMS into IRMS squared. So IRMS squared into Z into cos phi, right? So cos phi is equal to P average divided by IRMS squared into Z. So cos phi is equal to P average. P average is 2 divided by IRMS squared, that is 4, into Z, that is 1. So cos phi, that is the power factor. Okay, cos phi is equal to 1 divided by 2. Okay, 1 by 2, that is 0.5. 0.5. So the correct option is B. Okay. Next question. Question number 19. Sorry, question number 20. In Karnataka, the normal domestic power supply AC is 220 volt 50 hertz. Here 220 volt and 50 hertz refer to. Here 220 volt refers to VRMS, RMS value of the voltage, okay, and 50 hertz refers to frequency of the AC source. Frequency, okay. Option A says peak value of voltage, absolutely wrong, right? RMS value of the voltage, 220 volt is RMS value of the voltage, correct, and frequency, correct. So option B is the correct answer. Option C says mean value of the voltage and frequency, no, RMS value of the voltage, right? Option D says peak value of the voltage and angular, wrong. So the correct option is B. Question 21. A step-up transformer operates on a 230 volt line and load current 2 ampere. The ratio of primary and secondary windings 1:25, then the current in the primary. Okay, so here the load current is IS, isn't it? Load current is IS. Here the ratio of primary and secondary windings is 1:25, that is NP by NS is equal to 1/25. Now we need to find the current in the primary coil, right? IP, right? Now we know that NP by NS is equal to IS by IP, right? NP by NS is equal to IS by IP, right? IS is 2 ampere, IP we need to find, NP by NS is 1:25, that is 1/25, okay? So IS divided by IP is equal to 1/25, right? So IP is equal to IS into 25. So IP is equal to IS is 2 ampere into 25, that is 50 ampere. So the correct option is B. Okay. Next question, question number 22. The output of a step-down transformer is measured to be 48 volt, that is Vs is equal to 48 volt when connected to a 12 watt bulb. The value of peak current, that is we need to find I0, right? Not IRMS, I0. Okay, here the power P is equal to, or output power P is equal to Vs into Is, right? Isn't it? Vs into Is. This is the output power. So we need to find I0, right? In this case, Is 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 RMS, okay? Is RMS. And Vs is Vs RMS. RMS value of the Vs. Is RMS is RMS value of the Is. Now, Is is equal to P divided by Vs. Now, Is is equal to P. P is 12 watt divided by Vs. Vs is 48, right? So, this will be 1/4. Is is equal to 1 divided by 4, right? So, Is is RMS value of the Is, right? Isn't it? So, IRMS is equal to I0 divided by root 2, right? I0 divided by root 2. Here we know the value of Is, right? That is IRMS, right? Now I0 is equal to root 2 into IRMS, that is Is, right? I0 is equal to root 2 divided by 4. So I0 is equal to root of 2 divided by 16. So 2/16 is 1/8. So root of 1/8. So I0 is equal to 1 divided by 2 root 2. This is the peak value of the current. So the correct option is B. Okay. Yeah. Next question. Question number 23. The RMS value of the current in a 50 Hertz AC circuit is 6 ampere. Okay. IRMS is equal to 6 ampere. The frequency is 50 Hertz. The average value of AC current over a cycle. Direct question, right? The average value of AC current over a cycle is 0. Okay. And the derivation is given in the NCERT. Okay. Go through the derivation, you will get to know how we get the average value of the AC current over a full cycle is 0. Okay. Understood? Yeah. Next question. Question number 24. Or otherwise, you can go through the module also. Okay. Diksha module also. In there, they gave how the average value of the AC current over a full cycle is 0. Okay. Question number 24. A capacitor of capacitance 10 microfarad, that is C equal to 10 microfarad, is connected to an AC source and an AC ammeter. if the source voltage varies as V equal to 50 into root 2 sine of 100t. Okay, so what is the general equation here? The general equation of the AC source V equal to V naught into sine of omega t. Okay, the reading of the ammeter is, okay, we need to find the current, right? So compare these two equations, then we will get V naught is equal to 50 into root 2 volt, right? 50 into root 2 volt, omega equal to 100 radian per second. 100 radian per second. Okay, so we need to find reading of the ammeter, right? Okay, so here the reading of the ammeter, that is the current I is equal to Vrms divided by Z, right? Z is impedance. See, again read the question. A capacitor of capacitance 10 microfarad is connected to an AC source, that is it is purely capacitive circuit, right? There is no resistance, there is no inductor, right? So Vrms divided by, in this case Z is Xc, here Vrms divided by Xc, right? That is capacitive reactance, right? Now I is equal to Vrms, here V naught is given, right? How to find Vrms? Vrms is equal to V naught divided by root 2, right? So V naught by root 2 is 50 volt, right? So 50 divided by Xc, Xc is 1 divided by omega c, omega is 100 into c, c is 10 microfarad, right? 10 microfarad is 10 to the power minus 5 farad. Okay, 10 to the power minus 5 into 100 is 10 to the power minus 3, right? So I is equal to 50 by 1 by 10 to the power minus 3, that is 50 into 10 to the power minus 3 ampere. So I equal to 50 milliampere. Okay, so the correct option is A. Okay, yeah, next question, question number 25. In a series LCR circuit, the potential drop across LC and R respectively are 40 volt, 120 volt and 60 volt. Then the source voltage is, okay, here LCR circuit, LCR circuit, the potential drop across L is 40 volt. Okay, potential drop across C is 120 volt. Potential drop across R, here RCL, is 60 volt. Okay, so we need to find the source voltage. We know that V, that is the source voltage, is equal to VR square plus VL minus VC whole square, right? Now substitute the values, that's it. V equal to VR square is 60 square, okay, plus VL minus VC, VL minus VC. Okay, in this case VC is greater than VL, right? So we have to write VC minus VL. Okay, here it is VC minus VL. So VC minus VL is 120 minus 40, that is 80. Okay, 80 squared. So V equal to 100 volt. Okay, so the correct option is D. Okay, next question, question number 26. In a series LCR circuit, an alternating EMF V and current I are given by the equation V equal to V naught into sine of omega t, I equal to I naught into sine of omega t plus pi by 3. The average power dissipated in the circuit over a cycle of AC. Okay, average power dissipated in the circuit over a cycle of AC is Vrms into Irms cos phi. Okay, now here phi is phase difference, right? So what is the phase difference? Phase difference is pi by 3, right? Phase difference is pi by 3, isn't it? Here the phase is 0, right? Here it's pi by 3, so the phase difference is pi by 3. Now P average is equal to Vrms is V naught divided by root 2 into Irms is I naught divided by root 2 into cos phi. Cos phi is cos pi by 3. Cos pi by 3 is 1 by 2, right? So finally P average is equal to V naught I naught divided by 4, V naught I naught divided by 4. Okay, so the correct option is B. Understood? Next question. Question number 27. A transformer is used to light 100 watt 110 volt lamp from 220 volt mains. If the main current is 0.5 ampere, the efficiency of the transformer. Okay, so efficiency of the transformer is equal to output power divided by input power. Output power divided by input power. Okay, here we need to find efficiency of the lamp, right? Isn't, sorry, transformer. Okay, transformer is used to light 100 watt 110 volt lamp from 220 volt mains, right? That is Vp is equal to 220, right? Vp is equal to 220. Here P is equal to 100 watt, right? That is the output power, right? Output power is equal to 100 watt, right? If the main current is 0.5 ampere, right? That is IP is equal to 0.5 ampere, right? Now efficiency eta is equal to output power. Output power is 110 volt, right? Sorry, 100 watt, right? Output power is 100 watt, not 110 volt, 100 watt, divided by input power. Input power is Vp into IP. Vp into IP is 220 into 0.5. 220 into 0.5 is 110. So eta is equal to 100 divided by 110, right? Eta is equal to 100 by 110. So 10 will get cancelled. Eta is equal to here 10 by 11, right? 10 by 11. So 11.9s are 99, right? 9.9, and then 1 remained, right? Again take 00. Okay, so now eta is equal to 0.9, right? Now into 100%. Finally, the value of eta, that is efficiency, is equal to 90%. So the correct option is C. Okay. Next question. Question number 28. In an LCR circuit at resonance, the impedance is maximum. No, the impedance is minimum. Okay. Option A is wrong. The current leads the voltage by pi by 2. Wrong. Option C, the current and voltage are in phase. Correct. Right? The current and voltage are in phase. The current is minimum. Wrong, right? So the correct option is C. Okay. Next question. Question number 29. The average power dissipated in pure inductor. The average power dissipated in pure inductor is equal to IRMS into VRMS into cos phi, right? So in pure inductor, what is the value of phi? That is the phase difference. It's 90 degree, right? Voltage leads the current by 90 degree, right? So cos phi is cos 90 degree. Cos 90 degree is 0. So P average is equal to 0. So the correct option is B. Okay. Next question. Question number 30. A multimeter reads a voltage of a certain AC source as 100 volt. That is VRMS is equal to 100 volt. What is the peak value of the voltage of AC source? Direct question, right? So VRMS is equal to V naught, that is peak value of the voltage, by root 2. V naught is equal to VRMS into root 2. Okay. So V naught is equal to VRMS. VRMS is 100 volt into root 2 is 1.414. Okay. So 100 into 1.414 is 141.4. So V naught is equal to 141.4. This is the peak value of the voltage. So the correct option is A. Thank you so much. So if you love this video, please like and share. Okay, if you want to watch more videos, these kind of videos, please subscribe. Thank you.